In this video, I'm going to discuss one of the major challenges with cementing, and that is losing circulation or having losses while cementing. So behind me on board, I've got your hole with a string casing in. You're just about to cement your well. Now, one of the major reasons why you have problems with circulation or why you have losses during cementing is from the increased pressure. So your pressure, I'm actually going to write a formula for you, is your density times gravity times your height at any point in your well. So let's say we're at 1,000 meters deep, just for easy math. Your density typically of your drilling mud is somewhere around that 1,100 kilograms per cube. Density of your cement is going to be 1,700 kilograms per cube. Now, it might be a little bit higher and lower than that, but this will be awfully close to what you're going to see in your wellbore. The pressure when you've got your hole full of drilling mud prior to cementing at this point is going to be 10.7 MPa. The pressure when you actually have a full column of cement is going to be 16.7 MPa, or 56% higher. Now combined with that is how drilling mud works, or what you're trying to do with your drilling mud when you're drilling your hole is this 10.7 MPa is going to be higher than your formation pressure. And you want that because you don't want formation fluid flowing into your well as you're drilling. So you always have put a higher density in the hole so that you are putting pressure on the formation. Now, because you're putting pressure on the formation, that drilling fluid is going to want to leak off into your formation because you're higher pressure versus lower pressure. What drilling mud has is solids inside of it that create a little barrier called the filter cake. So as the liquid from your drilling mud squeezes into your formation, your solids from your drilling mud bind up against the formation face, creating a barrier called the filter cake. When you go to run your casing, because you want a good bond from your cement to your formation, you run scratchers on your casing that scratch the wall, scratch that filter cake off your formation so that you get cement up against the formation and get a good bond. Now you can imagine this is what's holding your fluid inside your wellbore, not letting it leak off. So you scratch that off, increase the pressure by 56%. When you go to cement, all of a sudden now you got more pressure and you've scraped a bunch of this filter cake off. That liquid's going to want to leak out into your formation, your cement will. So all of a sudden now if you got leaking going on here, you can have a couple problems. You might not get cement to surface, which is very bad because all of a sudden you got no isolation behind your casing at surface, and you're going to have to remediate that. You could still get some cement returns to surface, but it might be very poor and you could get very weak cement to surface. Or the third problem you can have is you get cement to surface and then the cement starts leaking off as it's trying to set up. If you start leaking cement off here, you're not going to get a good bond on this area, and all of a sudden you're going to have a bad cement bond log, or you might not pass your hydraulic isolation test, and you're going to have to go in and remediate it. Now you want to stop. You don't want to remediate because it's costly and it'll make a pain in the butt for your well for the rest of its life. So what do? The easiest thing you can do, because you can't reduce the density of your cement, and you don't get to try this density out before you do it. You get to cement one time, so you got to do something to increase your odds of success. What you can do is add a couple percent of lost circulation material in. Now this will increase the cost of your cement job slightly, but what lost circulation material is might be fiber or flakes. All it is stuff in the cement, so if your cement starts to leak off, those solids bind up against your formation wherever it's leaking off and prevents the cement from leaking off so that you get a good cement job. So you add that into your cement, all of a sudden it binds up here, stops your cement from leaking off, and you get a good cement job. So that's the easiest way to affect your cement job, and there's no real way of knowing if you're going to have problems with losses or leak offs during your cement job.